Okay, it says the functions f and g, so I circle those. What I'm trying to model as I work these problems in the videos is how I would actually work a problem on the AP test. I always go slow and careful because I've seen way too many students lose points simply because they rushed. So function g have continuous second derivatives. That might be important. That's kind of an interesting clue. Continuous second derivatives. The table above gives values of the functions and their derivatives at selected values. Okay. So here's a formula for k. Write an equation for the line tangent. I stop right there. Write an equation for the line tangent. So I look at my golden notes. I find this box. I've modified this box for this problem. Equation of a line tangent to k at x equal 3. So here's k, k. All right. So I remember this picture. So I'm at x equal 3. This is the graph of k. So this will be k of 3. So that's a good place to start. So we come over, this is the graph of k. Oops. Come back over here. So I write k of 3 is going to equal f of g of 3. So that's going to be f of g when x is 3 has a value of 6. So f of 6. And then f when x is 6 has a value of 4. So this is 4. So I've got my curve, which is k. Got a point on the curve at 3, 4. So good there. Now I need to find the derivative because k prime will find the slope right at this spot right here on the curve, which will be the same as the slope of a line that is tangent to the curve at that point. My board's a little out of calibration here, or I'm a little out of calibration, one of the two. Okay, so k prime. So k prime, this is going to require the chain rule because I have f of g. So this becomes f prime of g multiplied by g prime of x. Therefore, k prime, when x has a value of 3, is f prime of g with x equaling 3, g prime of x equal 3. So we already figured out that g, when x is 3, has a value of 6. G prime of 3 so g prime, when x is 3, has a value of 2. F prime, when x is 6, has a value of 5. So this will be 5 multiplied by 2, which is 10. So we can now write the equation of a line tangent using this formula here. So y is equal to 10 x subtract 3 plus 4. They give a lot of points for that. So they gave 2 points if you found, well, let's go one at a time. I believe they'll give you 1 point if you get to here. They'll give you another point if you successfully figure out that the slope is 10. And then they'll give you the final point for writing out the equation of the line tangent. So 3 points total on that problem. Go back and read the question just to make sure I didn't forget something. So here's the formula for k. Write an equation for the line tangent 2k at x equal 3. Yep, that's it. We're good. Okay.